Welcome back to our channel. In the last lesson, we learned the power rule. But what if our function has no x at all? Or if there's a number multiplying the function? Today, we'll look at the constant rule and the constant multiple rule. Let's begin with the constant rule. What does the constant rule state? It says the derivative of a constant is always 0. Why is it so? Because a constant is a flat line and the slope of a flat line is 0. So it is well stated and well written in our formula here above. The derivative of a constant is always 0, no matter what the constant is. So I'm going to take some examples in order to solidify this notion which we have just learned. Let's start with example 1. Find example 1. Find the derivative of 7. From our rule, we notice first of all that 7 here is a constant, and our rule says that the derivative of any constant is 0 no matter what the constant is. So we can conclude that the derivative of 7 gives us 0. No matter what the number is, the derivative of that number is 0. If we take another example, derivative of 100 still gives us 0. Derivative of 0 itself gives us 0. Derivative of 1 gives us 0. Derivative of any constant gives us 0. So let's move on to the next part, which is the constant multiplier rule or the constant multiple rule. What does this say? It says that if a function is multiplied by a constant, just keep the constant outside and differentiate the rest normally. So if a function here is multiplied by this constant, we can keep the constant and differentiate the function normally. So we're going to take some examples in order to solidify this notion we've just talked about. Example 2. Find d on the x of 5x cubed. So what can we notice here? In this case, we have a constant here 5 which is being multiplied by a function x cubed. And what does our law or our rule state? It said that differentiating this function is same thing as keeping the 5 or keeping the constant outside and differentiating the function normally. So derivative or differential of 5x cubed is same thing as keeping the 5 outside and differentiating the function normally. If we recall from our first video on the first rule of the differentiation where we use the limit, we differentiated this function. If we look into our last video where we use the power rule, we still differentiated the function similar to this. So we know that this derivative or this differential is the same thing as 3x squared using our power rule. So what can we then conclude? All of this gives us 5x. It gives us 5 times 3x squared, which gives us 15x squared. So therefore, the derivative or the differential of 5x cubed is equal to 15x squared. And that is our solution. Let's take another example and still solidify this fact. This one will be a practical example, a practical question. Practical question 1. Question 1. Find z on the x of half x to the power 4. If you want to tackle this question or if you want to solve this question on your own, feel free to pause the video, solve it, and then you can put your answers or paste your answers in the comment box, and each and every one of us are going to get down to it and give our own remarks and corrections if needed. So in order to differentiate this function, the first thing we need to do is identify the constant multiplier and identify the function itself. So first of all, half here is our constant multiplier and x to the power 4 is our function. The function, or the, how can I say, the unit function that we want to differentiate. So in order to differentiate this, all what we do is we keep the constant apart and differentiate the rest of the function the way we normally differentiate it. And what does this give us? Half times differential of x4 is 4 times x to the power 4 minus 1, which gives us half in bracket 4x cubed, which gives us 4 times half 2x cubed. So what can we then conclude? The differential with respect to x of our function half x4 is 2x cubed. Very simple solution. So we're going to move on to a third practice question, just still to ensure that it has been well understood. Practice question 3. Find d on the x of, let's say, 14x to the negative half. D on the x of 14x to the negative half, the same thing as we keep our 14 outside and we differentiate with respect to x, our function x to the negative half. What do we know? From our previous video, we differentiated this function, so we know that the answer of this is half. Let me put times and put all of this in bracket. Half x to the power negative half minus 1, which gives us 14 negative half x to the power minus 3 on 2, which gives us negative 7 x to the negative 3 on 2. So what can we then conclude? We can then conclude that the differential with respect to x of our function 14x to the negative half is equal to negative 7x to the negative 3 on 2. Yes. So in order to do a brief recap on all what we have done throughout this video, we went through how the constant rule and the constant multiplier rule. And what did the constant rule state? It stated that the differential of any constant, no matter what the constant is 0, and the differential of any function multiplied by a constant, in this case c, the constant multiplied by a function f of x, is same thing as keeping the constant outside and differentiating the function as we normally do. And so thank you for this video. In the next video, we are going to work on sum and difference rule. Yes, so till then, see you guys.